Okay, good morning, everyone. I'm D.Jimenez, and thank you, Emma, for the introduction. I'm a trained agronomist. I work for the International Center for Tropical Agriculture. As I said before, I'm a trained agronomist, and I'm also a data scientist. And the idea today, and I'm lucky enough to be the leader of this community of practice on data-driven agronomy. And actually, that's what I'm here to share with you what is the community of practice, what we're doing, what are the both challenges and opportunities working on data-driven agronomy. Then I will also talk about some of the results or what we propose in data-driven agronomy from the science perspective. I'll talk also about some of why it's very exciting working in this community. And at the end, and as I've been asked by the organizers, and talk a little bit about some of the lessons learned working on this domain. So data-driven agronomy. So its last name, agronomy. Agronomy, it's been out there for 150 years. What is new is the data-driven part, right? Its first name. So in order to produce food, a farmer must juggle with a set of variables, many variables that he cannot control, right? It's not only climate, it's not only soils, but also, for example, the site preparation, the decision of whether to establish a nursery or not, control of pests, weeds, diseases, fertilizers, irrigation, taking the production costs and in general the costs associated with taking action to deal with all of this. So the process is very complex, is non-linear, and farmers know very well that they cannot drop any of those balls if they want to succeed. So what is new, as I said before, is the data-driven systems that we've been here listening lately. Right? So the data-driven systems have opened the possibility not only to accelerate research in agriculture, but also to help us to make more informed decisions and more targeted decisions in terms of, for instance, what variety to grow, what is the best planting date, what is the right amount of fertilizer to spray. These are the type of things that are helping us lately to make agriculture much more efficient. So let me give you one example from the agronomic perspective, and this is an example that literally blew my mind months ago, because it's a huge paradigm shift for agronomists like me, because we've been hearing about the different classifications of herbicides, in one in particular, which is according to their action, right? If they are selective or non-selective, or total weed killers, as we call them sometimes. And this is something I've been listening for probably 20 years, and then it's very likely that it was born with the Green Revolution, right? So now it turns out that John Deere bought this company in Silicon Valley, Blue River, I think is the name. So what they have developed is, basically they were inspired by the algorithms used by Facebook and Google for image recognition. So what they did was put those software into the tractors. So now, let's say that we're growing maize, and we want to get rid of the broadleaf species. So now, the tractor goes across the field, and as long as it sees a broadleaf species, it will spray herbicide. But not only that, if it sees maize, it will spray fertilizer. So we've been talking about, I can tell you, over the last 20 years, sustainable agriculture, organic farming, eco-efficient agriculture, climate-smart agriculture, lately food systems, so many names for something that what we all want to do is make agriculture economically viable and environmentally friendly. And now we can see how technology is actually accelerating that process. But this is not a picture of a farmer in Cafrini, Senegal, right? This is a picture in the developed world. And probably the farmer that can afford to those services can even pay an extension agent to work with them, right? So who are the small-scale farmers? I mean, most of us work for them, right? So there is a fact. There are 570 million farms across the globe. 72% of them are small-scale farmers. Those are farmers that are not organized along the supply chain. They don't record information as part of their day-to-day activities, and they don't have extension services. And according to the FAO, they produce 80% of the world's food. So we made, and they're kind of behind of all this technological revolution. So that's why early this year, we, the community of practice, responded back to a paper written in Nature, that was talking about this technological revolution in agriculture. And we were telling them basically, yeah, you're kind of missing the vast majority of farmers in the world, right? So how can we, as community, work and make this data-driven agronomy, data-driven agriculture, data-driven farming more smallholder friendly, right? How can we democratize all these tools and make it available to everyone? So what we proposed, and at CIAT we've been working for already like 10 years on this approach, which is rather than conduct experimental trials, field trials, we've been collecting as much information as possible on farm, on the factors that might have an influence on yield, the factors that I mentioned in the beginning of the presentation, right? Productivity, and integrate that information into analytical techniques. And I don't want to go in depth explaining which data mining techniques, because lately we've been talking about that every single problem in agriculture may be solved with artificial intelligence, and I don't think that is the only techniques that can help us. Actually, I used to be one of the defenders of artificial intelligence because I did my PhD using those techniques, but I'm kind of sick right now of listening to everyone is using those techniques. It's like traditional statistics is not working anymore. What I do think is the combination of techniques. And there are cases where still traditional statistics are very useful. And when you work with both data scientists and traditional statistics, you will see that there's a compromise between them, right? I mean, sometimes the data scientists, they just don't respect basic statistical rules. And sometimes people working in computer science, traditional statisticians, they cannot see beyond the Gaussian distributions and normal distributions. So it's really challenging to find people that can understand both worlds, right? So at the end, once you use and integrate this information, what you're providing to farmers is what is the right planting date, what is the right amount of fertilizer to apply, what is the right amount of water that they should use. This is what we're proposing, and I'm bringing this example because this is something that Brian King talked in the beginning of the conference, and also was brought up by Derek, which is the example of rice in Colombia, where we have determined, for example, we've been working very closely with the National Growers Association, and by crunching some data, we basically found out that we still are growing varieties of rice in places where they should be grown because they are not well adapted to that site, to some sites across the country. But also for breeders, that's why I have this graph. This is by analyzing information in commercial conditions. So they can determine, for example, the functional relationship between the most relevant climatic factors and yield, right? This is something that in doing traditional agricultural research may take years of running experimental trials. And it was showcased in this booklet, written by the Open Data Institute and Golden, because it used both public and private information, right? The public information was from the Meteorological Institution in Colombia, which by law should make the data available. And it's very, something that also happened by doing this work is that we publish the results, we publish in the open access journal, and the National Growers Federation is part also of the authors of the authorship of the paper. So we talk to them and we say, look, we need to make the data available. So now they are aware that they gain more by sharing the information that they keep by themselves. So you can go to Dataverse and see how they're working right now. Some of the reasons why this is very exciting. This is something that more than 70,000 farmers had adopted across Latin America. We have analyzed more than 50,000 cropping events in 8 countries, recently in Ethiopia, more than 7 growers associations empowered with the tools. And we had some international recognition. But in 2014, we were the winners of the United Nations Big Data Climate Change. So we went to New York to present our results. In 2015, by the first Big Data Innovation Challenge by the World Bank. And the last year, we were winners of the Momentum for Change, organized by the United Nations in Bonn as part of the COP, for not only the CIAT's work, but also working with the CGIAR program on climate change. So in terms of development, we were good, right? Because we got the recognition of the United Nations. In terms of science, yeah, we're probably not the most prolific team at CIAT publishing, but we managed to publish some papers, and we were pioneers using this. Our first paper was in 2009, right? Like using artificial networks in agriculture. So recently we saw this challenge, Syngenta crop challenge in analytics. So I pushed very hard to the team because I knew the cards that we had to play. And this is different because when you publish, the reviewers will judge your manuscript and the results, but not the data set, the data set. So Syngenta make available their own data set. They make it available for the geek community around the world and then put people to compete. So the 5 finalists were invited to Baltimore. So we made it to the finals. And we were 3 universities, 1 private company, and us, the people working on research for development. We won. It turns out that we won. We won the Syngenta Crop Challenge. And we were very happy because it gave us, as Sabina was saying, like who's going to set the standards, right? I think we have some legitimacy right now to set the standards on analytics, right? I mean, we have published some papers, we have this good size background, and we made it. We beat private sector and universities around the world. So I think we have that. And this team, I have to tell you, like, about the lessons learned that Amon asked me to present, right? First, this team has to love what they do. This is research for development, and I'm going to tell you why. I mean, those guys, they could work for the private sector. And I'm going to tell you what is kind of frustrating with all of this. And first lesson, I hope that somewhere in the world, there's another meeting on communications and ontologies, because it is not Colombia, it's Colombia, right? This is the end of the country. But once again, it's like Colombians, you know, we're very sensitive with this. So the reason why I'm saying that those guys need the team, and women, don't worry about it. I mean, we also have ladies in the team. It's just that, you know, we went to Baltimore, just a few of us. So this is the framework that we followed. And I'm going to finish, Amon, no worries. This is the framework that we followed for the Syngenta Crop Challenge in analytics. So just imagine that, you know, there was the different steps, the data, how to process, the forecast, and then the prediction, and all that, So what is the step where we spent most of the time? Pre-processing. So the team spent 60% of the time, probably 70% of the time, organizing the data, and this is the cleanest, most structured database that we have ever processed. So just imagine the information coming from the developing world, right? You've been talking about plant height. We can have so many examples. GPAs coordinates to variety or germ plants, sometimes sowing date, planting date, harvest or yield. And when there are 2 words, they use low dash or dash and all the possible combination of doing that. So it's really very challenging. So the point here is like, we're kind of not very efficient, right? I mean, we achieved the things that we achieved with a team that spent 80% of the time cleaning data. Come on. So just imagine the world where we can really overcome all of that, right? So if we take seriously initiatives like the ones proposed by Meta, right? Like Guardian, the agronomic field book, the agroform, those are initiatives that we need to take that seriously, because I think that if we do that, the data should stop being a series of numbers and would be instead like something that can be actionable and help people to make more informed decisions in agriculture. That's it. Thank you very much.